So what we're talking about today are operations on functions. So taking two functions and we're going to add them, subtract them, multiply them, divide them. Okay, so this will be very interesting. Okay, and so the notation, this f plus g of x, this just means take f of x and add g of x. So take the two functions and add them together. The process of doing this is not very hard. Like if you can combine like terms in the functions, you should combine like terms. The tricky thing is the domain. So for domains, we think about, okay, what numbers can we put into the functions, right? And if you're going to put a number into the function, it has to work in the first function and in the second function, right? Does that make sense? So the domain of this is going to be the domain of f intersect domain of g. And that's the mathematical way of saying the numbers must work both in f and in g. Does that idea make sense? Okay. What do you think this f minus g in parentheses of x means? F of x minus g of x. And the similar reasoning for the domain applies. It has to work in f and it has to work in g. So it's domain f intersect domain g. Or what do you think is meant by fg? Morning. F of x times g of x. And once again, the domain is domain f intersect domain g. And then the final one, f over g, probably means division, f of x over g of x. And the domain is the same except for one thing.
0 for g.
Yeah, exactly. So, and g of x cannot equal 0. So whatever numbers would make that denominators, you've got to also leave them out. And like I think I said, the finding of f plus g, f minus g, f times g is often not very difficult. It's the domains that get a little bit tricky. And since every single domain involves the domain of f and the domain of g, I think the first thing you should do when you see a problem like this is just list the domains of f and g. And then you'll have to work with them once you've got them down. Okay, I'll move this up. Try to do it. Okay. All right, now, so these guys. Ish, okay. Okay, so this one is a pretty simple one to start with. The domains are also simple. What is the domain of 2x plus 3? Are there any numbers that you can't put into that? No. So the domain of f is negative infinity to infinity / all real numbers. How about x squared minus 4?
Nope.
Yep, so the domain of g is minus infinity to infinity. Oh, I'm sorry, you can't see that. There you go. Okay, so f plus g of x is just going to say take f of x, add on g of x. So take 2x plus 3 and add x squared minus 4. You're like, oh my gosh, it's so easy. Right? It is, okay. So just do that and rearrange the terms from highest power to lowest power. So you've got x squared plus 2x minus 1. And the domain of that function is f's domain intersected with g's domain, but since they're both all real numbers, this domain is also all real numbers. So this guy has domain all real numbers. Or you could say minus infinity to infinity. Subtraction is only slightly tricky in that you can't forget parentheses. If you're going to do f of x minus g of x, that's 2x plus 3 minus the quantity, x squared minus 4. That's the only way you can take away the entire function. So when that negative distributes, what happens to the sign on the x squared? And then we'll have plus 2x, and what is our constant? 7, very good, plus 7. And the domain is all real numbers. The domains won't get interesting until we get to part D. F of fg of x, this means f of x times g of x. So 2x plus 3 times x squared minus 4. Okay, so first distribute the 2x, and we'll have 2x to the third minus 8x, right? And then next comes plus 3x squared, and what's last?
Minus 12.
Yep. And it's better to rearrange them highest to lowest. There will be something that we're going to do later this semester. We're going to do long division with polynomials. And in that case, you have to do that. What is the domain of this function? All real numbers again. Okay, and then f over g. So that's f of x over g of x. So f of x is 2x plus 3 over what?
Square minus 4.
Mm-hmm. And usually if you can sort of simplify by factoring and canceling, you should, but that denominator just factors into x plus 2, x minus 2, and doesn't cancel with the 2x plus 3. Does that make sense? Now this is the first one that has a domain that isn't all real numbers. Because when you look at this, you've got to figure out when does x squared minus 4 equal 0?
Plus or minus 2.
If x equals plus or minus 2. So you have to leave those two numbers out in your domain because they're the two numbers that make that denominator 0. So as an interval, your domain is minus infinity to minus 2, union minus 2 to 2, and then 2 to infinity. Would the domain be the same if I had done the reciprocal? If I'd done g over f? So if I had done g over f, what would the domain have excluded?
2/3 or
Negative 2/3. Does that make sense? Negative 2/3 be the number that makes this 2x plus 3. Actually, no, it's 3 halves. 3 halves, because you have to minus the 3 and then divide by 2. Yep. Okay. So that's kind of the most basic example. The next one we have the operations, as in the adding, subtracting. Those are pretty simple, as though domains are a little bit tricky. Okay, so I have f of x is root x, and g of x is root 10 minus x. Find the following functions and their domains. So for part A, let's just write the domains right there. So for the domain, for this one, what would the domain of f be? All positives. So x is bigger than or equal to 0. Does that make sense? Or you could think about that as close bracket at 0 going up to infinity, right? The kicker is you can square root 0. And all positives. For the domain of g, the way to find it is to take the stuff inside the square root sign, which is 10 minus x, solve that bigger than or equal to 0. X is less than or equal to 10. Does it make sense how we got that, guys? You could either think he took away 10, then divided by negative 1, which flipped the sign, right? So that is negative infinity up to 10. And you can also check that by plugging in some numbers. Like if you plug in 11, are you going to get a real number result out of g of x? No, you won't, will you? You'll get negative 1, right? If you plug in like negative 100, is that going to be okay? You get 10 minus negative 100, the double negative makes addition, so plugging in negatives, as, past a certain point is totally fine. Okay, so f plus g of x, this will just be first function, root x, plus second function 10 minus x. And you can't actually like add them together because you have to do you guys heard about order operations, right? Like you do parentheses, exponents, and then other stuff, right? Technically a root's an exponent because you can't do the root, you can't do the other stuff. So that's done. But what's the domain of this function going to be?
Close bracket 0, 10.
Lowest bracket 0, highest bracket 10. Because you've got to be plug-inable in the first one and the second one, right? So if you want to draw a picture of that, you could say, okay, I've got everything from 0 on up, right? Everything from 10 on down. And I have to look for where those two things overlap, and they overlap between 0 and 10. Okay. What will f minus g be?
Root x minus square root of 10 minus x.
So that's what f minus g is. Does the domain of f minus g change from what the domain of f plus g was? No, same thing. So the domain here is also 0 to 10. Okay, f times g. So that's f of x times g of x. So root x times root 10 minus x. And you can actually multiply both of those roots together, it's totally fine. You get root x times 10 minus x, or root 10x minus x squared. And the domain here is no different than the domains for part A, B, or C. The domain is still 0 to 10. Okay, and then f over g will be a little bit more tricky. So that's f of x over g of x. What is f of x? Root x, right? Over root 10 minus x, right? You can actually write that as one big square root sign, x over 10 minus x. This domain, you have to leave out one of the numbers that you've been otherwise including, 10. So it'll be close bracket at 0, open bracket at 10. Okay. Oh man, fractions and fractions. All right, so given f of x is x over x plus 2, and g of x is x minus 4 over x plus 3, I can't keep that straight. Find f over g of x and find its domain. Okay, so first let's find the domain of f. Just tell me what's the one thing that x cannot equal. X cannot equal -2. And for the domain of g, what's the one thing x cannot equal? -3. Okay. Whew. So f of x over g of x. So your top fraction is x over x plus 2. Your bottom one is x minus 4 over x plus 3. Does that make sense? When you do division, what happens to the second fraction? It flips. And if you don't understand why that's true, you can think about, oh, well, I would multiply by x plus 3 over x minus 4 there, right? And also do the same thing here to keep fairness and preserve equality. That's why it reciprocates, right? Because doing that in the denominator cancels out to 1, right? Okay. Okay, so that's where that rule, like from elementary school, comes from. I've got x over x plus 2 times x plus 3 over x minus 4. So is everyone okay with that step? Okay, now at this step, you have another denominator. Does that make sense? So check and see, are there any numbers that you're going to have to leave out here? Yeah, you're going to have to leave out x cannot equal 4. Okay, and then just multiply them together. The numerator becomes x squared plus 3x. The denominator is x squared minus 4x plus 2x minus 8. So x squared plus 3x over x squared minus 2x minus 8. And I'm not 100% certain what Alex wants from you, but if you say x times x plus 3 over x plus 4 times x, that's x plus 4 is wrong, because it's not x plus 4, it's x plus 2, and now I can't erase because my app is stupid. X plus 2. I think that's also okay. So, like, if I don't legislate and say you must multiply these things out, you don't actually have to. Okay, and so for this one, for the domain, just tell me the things that x cannot equal. Mm-hmm. Mm-hmm. And 4. So x cannot equal those 3 things. 2 of which came from the denominator that the fraction has in the end, right? And then one of which came from the original denominator that got reciprocated and became a numerator. Okay, you all right with that? Yeah.
Is that all you write for the domain?
If you are asked to give it an interval notation, what would it look like? So negative infinity was the first number you leave out.
-3.
Mm-hmm. And then negative 3 was the next number you're going to leave out.
-2.
Mm-hmm. And then negative 2 up to 4, and then so it depends on which way you're asked to give them. Are you asked to give them that way in Alex, or are you allowed to give them as x cannot equal? Have we tried?
So far it's been used full notation.
Okay. That gets a little bit long for some of this stuff, so.
So why do you still put in -3s for the domain? Because is that for both the equations plus the new one you've created?
It's because the original expression was f over g, so you have to be defined in g. And since g of x has a denominator of x plus 3, even though it gets reciprocated, you still have to exclude it. So that's a technicality, but the whole thing is, since it was f over g is what it came from, you have to also leave that one thing out that would have made g undefined, even though it kind of went away when you flipped it. Is that what you were asking about?
Yeah.
Okay. All right, so the next one has slightly tricky domains. So I have f of x is x squared plus 7x plus 10, and g of x is 8 plus 2x minus x squared. This is a little bit related to what we were doing in class last time. At the very end, we were solving those inequalities with parabolas. So here, I think, is the best way to find domains. So take a look at the expression, x squared minus 7x plus 10. Okay, let that equal to y, okay? And I want you to find the X intercepts of this guy. How would you do that? Put 0 in for y. And factor, yep, that's what you said, right, Tyler? And it factors into x plus, no, shoot, x minus 5, x minus 2, right? Okay, if you were to sketch that parabola, just roughly, where would it cross the x-axis at 2 and 5, and is it going to be happy or sad? Happy. Okay, so there's your, roughly speaking, your happy parabola. Okay, now you can square root this expression if that expression is positive, right? So how is that expression being positive related to the graph of the parabola?
Everything between 2 and 5 seems to be
Everything between 2 and 5, this stuff is negative, right? Everything before 2 and after 5 is positive. So that picture tells you that the domain of this thing is all the numbers from there to there, and all the numbers from here to here. Those are all okay. If you were to like take a graphing app and graph that original function, it's gonna have a big old chunk missing in the middle. And the big old chunk will correspond to the part of the parabola that is below the x-axis. Okay? So this guy's domain is negative infinity to 2, and it includes 2 because you can square root 0. And also includes 5 to infinity. And the reason that's related to what we did last time on Friday is technically you're solving x squared minus 7x plus 10 bigger than or equal to 0. Like that's what you're doing. So okay, so that's for f. I'm just going to do g over here because the f plus and the f over is like not that hard. So domain for g. So g is 8 plus 2x minus x squared. We'll call that y. And we'll find the x intercepts by plugging in 0 for y. Shoot. That one is slightly more tricky because the factor patterns that you have only work for positive x squareds. Does that make sense? So does it make sense that you could take this whole thing and you could divide it by -1, and that will make it so you have positive x squareds? So you have positive x squared minus 2x minus 8 equals 0. And now you can factor x minus 4.
Yes, okay.
X plus 2. So where would that parabola cross the x-axis?
4, -2.
Great, -2, 4. And when looking at the whole upside down or right side up, look at the original thing. Would the original one have been upside down or right side up? Upside down, would have been sad. So what would the domain of g be then? What numbers can you plug into g? Everything between -2 and 4. Exactly. Okay. And really with these problems, that's the hardest part, is getting the domain of f and the domain of g. And honestly, if I give you a quiz question, I'm probably going to break it down into parts so it's not such a monstrosity for the grader to grade. Does that make sense? Okay. All right, now moving back on to the actual question at hand, which was to find f of x plus g of x. So that will equal root x squared minus 7x plus 10 plus root 8 plus 2x minus x squared. And you can't do anything else to it. That's it. Okay. So for the domain of this guy, oh, you've got to look for where those things overlap, which is a little bit tricky. I think I'm going to draw a picture. You guys have those on your paper, so I'm just going to move this up so I can draw a picture. So the first one was everything up until 2, right? And everything past 5, is that correct? Okay, there's one of them. And the other one, what was it? Everything from -2 up to 4. So you've got to look for where do those two things overlap, and where do they overlap? -2 to 2. Oh, but that should say -2, so sorry. -2 to 2. The next one was division, right? This next one was f of x over g of x, is that right? So root x squared minus 7x plus 10 over root 8 plus 2x minus x squared. Technically, maybe something would factor and cancel, but I don't think it does in this case. How can you tell that nothing can cancel?
That's when you factor them out.
Yep, I factored them out, like, here, right? And none of the factors are the same, so they're not going to cancel. Okay, so there's f over g. And you know you're going to have this interval -2 to 2, but you might leave something out. Now, this fraction, this one right there, that corresponded to the denominator, right, in factored form. Does that make sense? So what number from my domain do I have to leave out? -2. So this domain will be -2 with parenthesis, 2 with square bracket. And you could double check that by plugging -2 in and seeing, does it actually give you a 0 in the denominator? And it does, because 2 times -2 is -4, right? Then you square the -2, which gives you 4. 8 minus 4 will give you 0 on the bottom again.
So why don't you include 4 exactly?
You don't include 4 because 4 isn't in the domain of the numerator,
Okay.
right? Because you have to work in this part and in that part, right?
Yeah.
And so since 4 is out the domain of the first one, the root
Yeah,
x
you
squared.
would end up with the imaginary numerator.
Exactly, and a real denominator, and that's also not okay. Yep, exactly. Okay. So one more of these, and then we'll talk about this new thing called composition. So given f of x is 2 minus x, and g of x is root 3 minus x, find the following values. So no domains, anything like that, just f, g minus f of -5. So that means do g of -5 and take away f of -5. And what does g of -5 mean you should do? In for x. So that gives me root 3 minus -5, so is that going to be okay? In the end? Yes. Minus quantity, 2 minus -5. Oh, those double negatives. So that's square root of 8 minus 7. Do we agree with that? Now, it's kind of like reducing fractions to lowest terms. If you can reduce square roots, you should do it. So, for example, with 8, you know that 8 is equal to 4 times 2. So that root 8 can become 2 root 2. And your calc teacher might take for granted that you can actually do that, so they might not even explicitly state it in directions. I usually try to do so, or always do it in class, but just FYI, it's assumed that you know how to do that. Okay, f over g of 3. That's going to be undefined. That's f of 3 over g of 3. And since g of 3 is equal to 0, this is undefined. Okay, how about fg of negative 7? So that means do f of negative 7 times g of negative 7, right? So what do you get when you plug negative 7 into f? 9. How about when you plug negative 7 into g? Square root of 10. Does root 10 simplify? No, it's just, it is what it is. You got 9 roots of 10. Okay, so adding, subtracting, multiplying, dividing, not very hard, except for the domains are a little bit tricky. Do you guys agree with that? So we'll do more domain finding tomorrow as well. So we're going to do 2 days on this section. I'll do 2 days on section 3.6 as well. So I'll have 2 sections on your quiz. So the next thing is something called composition. So composition is when you take one function and you put it into the other function. And that involves doing 2 things in succession. And this is the notation. The notation is a little circle. That circle usually is read, how I've seen it is read f of g of x. Kind of like this f parenthesis x means f of x notation, right? So this f of g corresponds to f parenthesis g parenthesis x, which technically means that g goes into f, because the thing in parentheses is your input. Does that make sense? Okay. And the best sort of real life example that I found of something where this happens is getting discounts. So this probably doesn't happen super often in real life, that you're offered a discount and a choice in which you do it, but there's a reason that stores do stuff in the way that they do. So if they're gonna offer you a rebate and then a % discount, they're probably gonna give you the rebate first and then the % discount. And here's why. So suppose you're buying a pair of shoes. They normally cost $100. You have a coupon, $20 off, and the shoes are 50% off. And we're going to pretend that they're going to let you choose which way you're going to do these deductions in. So do you want to do the 50% discount off first, or do you want to do $20 off first? What's the difference going to be? Okay? So if you do 50% off first, your original price is $100, right? 50% off, what does that make your price? $50, okay? Minus $20 is going to give you a total price of $30, okay? So what if you get the $20 off first? The original price is $100, right? Minus your rebate gives you, the cost is now $80. And then your 50% off brings it down to
40.
So you see how it matters which discount you do first? Okay? And how that translates into function notation, suppose that your f of x is 0.5x. What's that function doing? That's giving you half the original price, right? 50% off. How would you represent taking $20 off as a function? If x is the original price, it'd be x minus 20. Okay. So doing the 50% off first, that corresponds to g of f of x, or g parenthesis f of x. Because you would work this one out first, and then once you've got an answer, you do g on it. And this one corresponds to, what do you do first here? You do the 20 off first, right? And do the 50% off last. That's f of g of x. So that happens first, and that happens second. If you think about the parentheses, first you do this thing, then do the next thing. Now, if you have a chance to outsmart a store, you can, right? Or if you are the store's manager, which way are you going to give discounts? If you own the store, you want to make money, right? So you pick the option that makes you more money, right? You pick this one, yes? If you are the customer and you want to save more money, you pick the second one, right? First one. Okay. All right, so let's talk about how to find the values of these functions using this first one is a little table of values. So for me, personally, the first thing that I always do is take that and make this into f of g of x. I make it back into parentheses because that makes more sense to me than the little circle does. And then I think, oh, well, you know, back when I was in, I don't know, junior high, we were told to do PEMDAS, and I do the stuff in parentheses first, right? I made a slight boo-boo here, and that boo-boo is that what should that be instead of x? Should be 10. So this should say f of g of 10. So sorry. So parentheses first, the g of 10 is the thing that's inside the parentheses, right? So first work out what that is. And look at your table. You go down to where the x is 10. When you plug 10 into g, what do you get? -8. So that becomes f of -8. And then you think, okay, when I plug -8 in, what comes out of my f function? Just look, when x is -8, f is 12. Next one, f of g of 0. So work out what g of 0 is. So what is g of 0? -4, very good. And what is f of -4? 18, great. And this operation is different than addition and subtraction, like not the same, or multiplication, it's completely new. Okay. Last page. All right, so given f of x, woo, I'm sure it's lots of fun to watch me mess with my technology. Given f of x is 2 minus x and g of x is √3 minus x, find the following. So g of f of 1. So we're on page 4 of the first sheet. Okay, you got it, all right. Okay, so we have, when you plug 1 into f, what do you get?
-1. And the 1.
1. Does that make sense to the rest of you guys, how we got that? So I took this 1. 1 got plugged into f. 2 minus 1 is 1, right? Now what do you do with that 1? Put it into the g. So √3 minus 1 gives you square root of 2. Okay, and then g of -7, well, let's translate that into g of -7. So inside 1 first, you plug -7 into g, which gets you square root of 3 minus -7, right? So what is that? So √10. And then what do you do with that √10?
Plug it back in.
Plug it into g. And I think that there might be a slight issue here. Yeah, √10, this thing is actually bigger than 3. Because √9 is exactly 3, right? And 10 is bigger than 9, so √10 is bigger than √9, right? So technically speaking, this one is also undefined. That'd be a bit tricky to catch, and if you were uncertain, like, and you're at home and you're just like figuring stuff out, you could check and find root 10 in a calculator and verify that it is indeed bigger than 3, and therefore 3 minus number bigger than 3 is problematic in a square root sign. So, okay. So that is finding compositions for specific numbers. It gets annoying to do the same operations repeatedly. Does that make sense? So it's often better to find a formula. So, which means you're going to do the same operations, but with x's in them. So, for example, here we go. We got f of g of x. So that's f parenthesis g parenthesis x. And then you ask yourself, what is g of x equal to?
4x minus 1.
Okay, so that's f of 4x minus 1. Everybody okay with that? Just replace g with what it's equal to. And now what does f parenthesis 4x minus 1 mean that you should do?
The for x for the f.
You should plug this in for all of this function's x's. So that x gets replaced by 4x minus 1, this x gets replaced by 4x minus 1, and then you should simplify. So this is now 4x minus 1 squared plus 2 times 4x minus 1 minus 11. I mean, same thing like f of 3 would mean plug 3 in for all the x's, right? This just means plug in 4x minus 1 for all the x's. So it went in there and there. And then from there you should simplify. So how do you simplify 4x minus 1 squared?
16x minus 8x plus 1.
I'm gonna write 4x minus 1 twice because you just made a mistake. Oh, no, you didn't. You said 8x. Never mind. I'm wrong. You're right. So 16x squared, I'm sorry, minus 8x plus 1. You guys see how I got that? Okay, I shouldn't doubt. Be a believer. Plus 8x minus 2 minus 11, which is 8x minus 13. And then once you're at there, just combine like terms. So you've got 16x squared. What happens to your x's?
They cancel.
They cancel, and then you have minus a constant of 12.
Negative 12.
Yep, so 16x squared minus 12. Great. Now speculation, will g composed with f be the same thing? Was it the same? It wasn't the same thing for our discount problem, right? So this is an example of a non-commutative operation, meaning the order actually matters, kind of like subtraction and division. Okay. So that's g of f, or g of f is equal to x squared plus 2x minus 11, right? And then the x squared plus 2x minus 11 goes into g's x's. So 4 times x squared plus 2x minus 11 minus 1. So this replaced that. See, there it is. Is that one easier or harder to simplify than the previous one?
Probably easier.
A lot easier, yeah. So you've got 4x squared plus 8x minus 44 minus 1, which is 4x squared plus 8x minus 45. Okay. I didn't bother with domains on this one because the domains are easy. Does that make sense as well? Both of the original functions have domains, all real numbers, and so the resulting function will have domain, all real numbers. The next one's a bit more tricky with the domain, and even though the composition is not that bad. So did I change yours? I changed yours to just say f of g because it turns out that g of f, the domain is sufficiently complicated. I didn't want to go that icky with you. So to start, let's find the domain of f and g, both of them. So for f, we're going to say let 9 minus x squared without the root just equal y. And like before, we're going to find the x intercepts of that parabola. So set 9 minus x squared equal to 0. So 9 will equal x squared, and what two numbers does x equal? 3 and negative 3, plus minus 3. And if you were to graph that 9 minus x squared, what would it look like? Happy or sad?
Sad.
It'd be a sad parabola. I think we actually briefly discussed that. I know I've discussed a lot of stuff with you in this class. It's hard to remember it all, but technically speaking, that 9 minus x squared rooted makes the top half of a circle. I think we talked about that, how if you want to graph a circle in a calculator, you've got to solve the x squared plus y squared equals 9 for the y, and you'll have a plus minus there. So it technically, when you graph this and you square root this, you get a circle. Okay, so based on that picture, when is the 9 minus x squared stuff positive? So the domain of f is negative 3 to 3. Okay, I think we're not going to explicitly need it, but the domain of, we will need it. The domain of g does it make sense that that one is going to be 1 to infinity? Anything lower than 1, you'll get a negative inside that square root sign. Higher than 1's okay. Okay, so let's find f of g of x. So that's f of g of x. Or f of square root x minus 1. Is everyone okay with what went where? Okay. At that stage, because you're somehow involving the root x minus 1, no matter what happens to it in the simplification process, you have to have that x is bigger than or equal to 1 at that stage, because the numbers that you're plugging in have to technically work in g before you plug them into f. Okay, so just put that in your back pocket right there, that you're going to need to have that restriction. Okay, then when you plug that root into the f function, it goes in for that x. And you get square root 9 minus square root x minus 1 squared. And you are totally allowed to simplify. Do you know what I mean by that? What happens when you square x minus 1? Poof. Now here's one place where you could mess up. 9 minus x minus 1. That's wrong. Because you'd taken away this whole expression, right? And that square root kind of acted like a parenthesis. Does that make sense? So to make this right, you have to put parentheses around it. Okay, so that simplifies to square root of what minus x? No. Because the negative distributes makes that a positive. Oh, duh, yes. I did it wrong on my notes. I had parentheses and I wrote 8. 10 minus x, yes. Okay. And then look at this thing and find the domain of it. So the domain here, we have to have 10 minus x bigger than or equal to 0. So that implies that 10 is bigger than or equal to x, or x is less than or equal to 10. So if all you were given was this 10 minus x and said find the domain, then you'd say, okay, x is less than or equal to 10 minus infinity to 10, okay? But because it came from a composition, you also have to restrict it with this stuff. Okay, so you have to also incorporate, okay, well, x has to be bigger than or equal to 1 and less than or equal to 10. So this domain, technically for this composition, is 1 to 10. That's kind of like with the multiplication ones, if you took away the negatives when you multiplied. Yeah?
So why aren't you using the other domain?
You don't use the other domain. It's a great question. I don't know if I have a spectacularly awesome answer. The other domain would be used if you composed in the other order. Does that make sense? But the way you find the domain of the f function is that comes up when you do this root 10 minus x part. So that domain is kind of changed by what you've plugged in, and you account for it at the end. And you need to account for the domain of the thing you're plugging in at the beginning. So if I'd switched the composition, then you would have restricted that first domain and then looked at the answer and restricted the domain even further. So we'll do more of those tomorrow, but the opposite order didn't work out quite as nicely, and the book wasn't asking you to do one that complicated, so I left it out. Okay, so that's it.